All right, ladies and gentlemen, we're going to do a redox problem from, I can't remember exactly, but I'm pretty sure it was fall 14. Part 2. Yours will be similar. Stretch it out a little bit. Trying to get my thingy out of the, oh, look at that. Just trouble. There's just trouble everywhere. I can't grab the one. There you go. So when you do any atom's oxidation state from now on, you just look at every bond that atom has and add up the numbers according to this guide. If you were bonded to a more electronegative element, that means you get a +1 for that bond. You're feeling positive when you're bonded to a more negative atom. It should make sense, right? The electrons are getting pulled away from you. You get a -1 for a bond to a less has one S. I think you figured it out. Why? Well, you're bonded to a less electronegative element means the electrons are getting closer to you. That means you're feeling negative. How much? -1. And you get a 0 if you're bonded to an atom with the same electronegativity. What's going to happen here? I see carbon and sulfur in the same molecule. CSI, all three of those elements are 2.5. I know that. We're going to start by drawing Lewis structures for species 1 and 4. Here's species 1. The carbons in species 1, 1, 2, 3, 1, 2, 3, end up being the carbons in species 4. 1, 2, 3, 1, 2, 3. And species 1 looks like this. C with an H. Don't forget, it's Lewis. Don't leave it like that. What's missing on that oxygen? 2 lone pairs. You are correct. Uno, duo. And that's species 1. Species 4. It's written condensed. If you're thinking species 4 has the possibility of being an ether, then you will have formal charges in what you draw, and it will be wrong. The only way to avoid formal charges with that condensed structure is to realize that's a carbonyl in the middle. That is a ketone. I'm going to pull a fast one on you now. Move my box. Because I want a copy of these two things. That's all. That's the only reason I did that. Move my box and the numbers up. Not just the box. There we go. Paste. I'm going to paste this up here with those red sentences right beside, and realize that, and this is, I had a lot of trouble this morning. This is Roman numeral little I, second carbon of species 1, which is this. I's that sulfur down there. What about species 4? That's going to be atom. The carbonyl in species 4 is right there. That's IV right there. Every bond that I has, I'm going to give a number to. There better be 4 numbers. It's carbon. What do you get for carbon bonded to carbon? It's 3, isn't it? You get a 0. And I got to be very clear, else I can get in trouble. These numbers are ox state. That's oxidation state. They are not formal charges. That's why I'm doing them outside the Lewis box, because you might think they're formal charges. You get a 0 for a bond to carbon, and you get a 0 for a bond to the other carbon. What do you get for the carbon bonded to the oxygen, which is more electronegative? +1. Carbon gets a +1 for that bond. Doesn't look very clear. +1. What does it get for the bond below, for a bond to H, which is less electronegative? You add up all those numbers, what are you getting for I? It's a 0, a +1, a 0, and a -1. Big fat 0. For I got to make sure I'm putting labels in the right boxes. This morning was a disaster. Okay. Might as well go to species 4, because that carbon underwent a change to become this carbon. You get 0s for the bonds to carbon again. Don't forget, each bond has the same question. What's the oxidation state for the bond? I don't care if it's pi or sigma. Same story, each one. Carbon bonded to a less electronegative, more electronegative oxygen. +1 for that bond, +1 for that bond. Add up all your numbers. 0, +1, +1, and 0. What do you got? 2, and that's for IV. What do you call the change when your oxidation state goes up? Oxidation or reduction? Reduction, your gain. Remember your old definition? What was your old definition of reduction? Now you can use it because numbers are perfect for it. Gain of electrons is reduction. So you're gaining negative charges to get reduction. Your charges are going down. Okay, so what happens for your oxidation? You get a higher oxidation state, right? Oxidation, higher oxidation state, make sense? Oxidation is a word, right? If the number is going up, it's oxidation. If it's going down, it's the opposite of oxidation, reduction. So we say that I is becoming oxidized, oxidation. And I is becoming oxidized. All right, now how about going over to molecule species 2 and looking at II? What does sulfur get for a bond to carbon? They both have an electronegativity of 2.5. 0. And for the, wow, also there. But it gets a +1 for the bond to oxygen on the right and a +1 for the oxygen bond to the left. That's 2 pluses. Go to sulfur on the other side of the equation. V, 0 for a bond to carbon, 0 for a bond to carbon. That's 0. So +2 went to 0. What do you call that? +2 going to 0. +2. Oh, I'm trying to see myself on screen. +2. This is it's going down. It's reduction. I'm gonna write that down. So we say that II underwent reduction. That's baby blue. What about III? To do that, we got to look at what happened to these two carbons, and they ended up here and here, didn't they? Yeah, but we only care about this one. These two carbons ended up as these two carbons, okay? So what do you get for a bond to a more electronegative Cl? +1. We'll do that in orange. That looks, I got to do it underneath. +1 for the chlorine, +1 for the oxygen, +1 for the oxygen, 0 for the carbon-carbon. That's a +3, right? I think we better draw this VI down here. Isn't that what CO2 looks like? What's the oxidation state on this carbon, which is VI? +4. You got a +1, a +1, a +1, and a +1. +4. We had 2 species undergoing oxidation, huh? I have to do that in gray. Oxidation, it went up. So species III also oxidized. And we're doing that in orange. III. Now, I've heard a lot of things memorized by students for what is a reducing agent, what is an oxidizing agent. Okay, you just get it out of your head. Stop. If an atom becomes oxidized in a reaction, it's the other molecule that caused that. And what agent means is it causes that. So if you're a reducing agent, you are causing reduction to another species. If you are an oxidizing agent, you are causing oxidation in another species. That's the only definition. Don't invent your own ones, like saying the oxidizing agent became reduced. That has nothing to do with the definition. That's a coincidence. It's an artifact. There's you're not showing me understand chemistry when you're saying stuff like that. Okay, so I'm just going to identify in this species, atom 3 got oxidized, and that was atom 3 got oxidized. And in this species, atom 1 got oxidized. So 3 got oxidized and 1 got oxidized. Well, what's the only chemical we haven't talked about? Because it's the one that caused it. Species 3 had an atom that got oxidized. Species 1 that had an atom that also became oxidized. They did not cause oxidation of each other, trust me. Oxidation does not cause an oxidation in another species. You got oxidized. The only species we didn't talk about is the sulfur species, and it was the oxidizing agent, species 2. Reducing agent, well, this is the atom that got reduced. If the other 2 molecules weren't around, then it wouldn't have happened. You see how easy this works out easier than you thought. Identify the thing that got oxidized, and it's the other things that caused it. If there's only one other thing, and it's the other thing. But in this case, there's 2 other things, right? This is the only species that got reduced. What caused that reduction? Species 1 and 3. And there you go. And I think that's the only semester in a lot of these where there was like 2 answers on one line. Most often it's just one answer for every line. So what would happen if you missed one of these 2? You wouldn't lose a half point. You'd lose a quarter point. Or are they 1 point per box? Does it say somewhere? 2 points each. 2 points. Oxidation states. Oh, 1 point each for B, C, D, and E. Yep. B, C, D, E, and it should have said F. So you'd lose a half point if you only put 1 in that box. And that's all I got for that.